Hi guys, today's video is going to be over convergent boundaries where two continents actually are meeting up along a boundary. So let's write that down. Convergent or convergence, continent boundary. All right, so as you can imagine, when two massive land masses are coming together, so these massive blocks are coming together, you can imagine that that's going to be quite interesting. Obviously, we're not going to have a lot of subduction, but there might be some minor subduction of making one plate, one continental plate, a little bit more dense than the other. But if we look at this, so we have two plates coming together. As I said, there might be some little subduction, not very much, literally because they're of equal density, but as we have them come together, and this is a good visual for you guys, you can see that since they are equal, or pretty close to equal in density, they're going to just converge or collide, come together, and what do you notice building up? Well, if you're noticing, there's kind of like a whole bunch of folding and things going on. What would this equate to, you think, if it was something that we could actually observe on land? If you said it would be an example of how mountains build, you're absolutely correct, because convergence between two continents or along a boundary between the plates carrying land on each side or continents on each side results in exactly that. It results in the formation of mountains. So the plates are coming together, each carrying continent. We're going to use an example here because this is what's happening at where the Indian plate, it's carrying continent on its along the boundary, and the Eurasian plate is carrying continent along its boundary, and here's where we are making mountains. The example that we're using here is the Himalayan mountains. So this is how these mountains are being built still today. These two plates are converging and building these mountains. But of course, convergence or any plate motion is rather slow. So on the surface of the, you don't see as much folding as we did with our tiles when we used them as an example. But you're going to see ragged peaks and things like that, because in the meantime, what's happening on land, and if y'all remember way back when you studied weathering and erosion, that's what's exactly going on with these, making these actual initial folded mountains more peaky, because on land, weathering through water, wind is and ice is eroding or breaking down the rock, and then erosion is moving that rock away, making these once folded mountains more peaky. So let's look on our map and see where this is occurring exactly. We just said it was occurring between the Indian plate and the Eurasian plate, which is right here. This is the Indian plate. This is the Eurasian plate. They're coming together here. and we are forming mountains. So that's my mountains. Those are our Himalayan mountains right there, and that's how they're being formed. All right, another boundary that I would like to look over with you today is when we have two plates converging. One is carrying ocean along its boundary and the other is carrying ocean along its boundary. So we're going to do convergence, ocean, ocean. So let's look at what that looks like. Remember, once again, convergence is coming together. So the plates will be moving together like this. When we have ocean-ocean convergence, we do have a plate that is a little bit more dense. So we will have what we call, what do we call that when one goes beneath the other and melts down? You said subduction. You're absolutely right. And we'll have one that kind of rides along the top. In this example, we're going to use an area where the Pacific plate, meets up with the Atlantic, or actually it's the North American plate, but along the Atlantic Ocean. So let's put North American plate because that's correct. And if I said Atlantic Ocean, I mean Pacific. Sorry, guys. So, but these are both, this is all underwater. So we're under the ocean floor. So obviously you see that we have one plate subducting beneath the other. And we already know that when subduction occurs, we are going to get melting. So we're subducting here. So it just means it's going down beneath the other one. See, they're still moving together. The arrows might show this, but you guys need to understand these are still moving together, even if one is moving below the other. And we know exactly what's beneath those plates. Well, we have our asthenosphere with our convection currents. And we know since they're moving together, warm must be rising, pushing them together like this. And cool must be sinking. So this is kind of how they're being moved like on a conveyor belt towards one another. Now, they're both underneath the ocean, but what's happening here, remember when these plates begin to subduct into the asthenosphere, they begin their meltdown. So this is going to start melting down, all of this. And it's going to add to the magma pot directly here underneath this part of that North American plate carrying Pacific Ocean waters. So this magma here is going to rise, and we are going to create, and I know y'all already know what this is because we've talked about it. What does that create? Well, yeah, it creates volcanoes. So this is going to be volcanoes that rise up in kind of a line where this is taking place. And these volcanoes that are rising up are referred to as volcanic island because they're islands in the middle of the ocean. Arcs. These are volcanic island arcs. So there you'll see this where they come together, these two plates, along the one plate that's overriding the subducted plate. You get that magma pot that rises to the surface and creates those volcanic island arcs. Our example of this is the Aleutian Islands. And it's literally called a Aleutian Island Arc. Okay, so we refer to this as the Pacific Plate being subducted under the North American Plate, both where they're under ocean. Let's look at that on our map. If we look back at our map, here you can see this is our Pacific Plate. The Pacific Plate carries mainly the Pacific Ocean. So it's being subducted here, meaning it's going beneath the North American Plate, and here's part of the Pacific Ocean on the North American Plate. So it's as it moves beneath along that boundary, the line you see directly here along this boundary, but on the North American side, or actually, yeah, on the North American Plate side, you see all of these volcanoes, volcanic islands, and this right here is known as the Aleutian Island Arc. So that's our example for convergence, ocean-ocean convergence, two plates carrying ocean on either side, them coming together and what's being created. So that is our Aleutian Island Arc. There are some questions students often ask. So let's just take a quick look here at this picture. The Pacific Plate is being subducted pretty much in all directions, which means ultimately this plate will no longer exist. What's happening is that this will bring North America and Eurasia closer together, because remember here they're moving apart in the Atlantic Ocean, but they are coming together here because this plate is going away or being subducted, melted down again. So once again, we're creating new crust here. We're getting rid of crust in these areas. And then students ask, well, what's going to happen to the ocean? Okay, so the oceans are all connected. If you look at the globe, the oceans are all connected. So the water's not going to disappear. Ultimately, as this comes closer together and the Pacific Ocean can't be here, that water, then because this is being made here, crust is being made here, the Atlantic Ocean will get bigger. So the water is just going to gradually be moved to that location because all these oceans are interconnected. So I hope that helps clarify some questions that you may have. I think that as of right now, this video is good to go. Of course, you guys can ask me any kind of questions you have tomorrow during our class office hour time. All right, you guys, have a great afternoon, and I'll talk to you later. Bye.